Good afternoon, everybody. My name is Keith Roseland Barnes. I've been the CRO at Unravel now for just about 4 months. On my journey here, I've spent the last 10 plus years in the traditional data space at Oracle. I moved to the Hadoop world with Hortonworks and then Cloudera. And then I spent the past 3 years building a startup in the automated machine learning and ML ops space. During this time, the concept of responsible self-service across data analytics and data science has evolved from a nice to have to a requirement for success. I'm thrilled to be here today with you to talk about simplified self-service for your evolving modern data stack. As we walk through the presentation today, we're going to touch on four key points, sorry. The fact that we know every company is a data company, challenges for data teams, enabling self-service approach, and what excellence really looks like in this space. And I'll definitely make sure that Dave and I have a chance for Q&A at the end. As the world moves to consume more and more and more data, companies in every industry are becoming data-driven. Now, while this seems like a relatively nascent statement, the implications around talent, process, and how companies operate are substantial. Success in this area requires evolution across operating models, funding mechanisms, team composition and collaboration, skill sets, performance and cost management. Now, while doing this at scale in a world moving to self-service can seem like a very daunting task, doing this responsibly at scale without the use of AI to augment your staff is pretty much impossible. I read a post recently that the average tenure of a chief data officer is less than 18 months. Just think about that for a minute. In large, complex companies, it could take up to 12 months to actually get a process changed. Yet the time these folks are in their roles is barely long enough to see the impact of any change from that process, let alone the implementation and rollout of a new technology. Now, the key reasons why many feel that this is the case is increasingly because it's very hard to demonstrate and show business value unless you combine the data with analytics into a CDAO role. Now, while both drive change, business value is much easier to see when looking at analytics versus purely looking at data. Now, when we dig into that a bit further, what we've seen from a recent survey is that many of the key challenges that data teams face are more around cost, efficiency, quality, governance, alerting, seemingly nothing to do with visible business value that gets the majority of corporate attention. None of these things are sexy. None of these things are the first thing on a slide in a board meeting. But when you look at this, you can understand how it becomes very difficult for a CDO or a chief data officer to point to and show real true business value from these key focus areas, unless they are looking at these things like breathing, just something that happens naturally that doesn't get a lot of attention. When you set up an environment where you have these things solved for, it provides confidence throughout your data pipelines and allows your data teams to focus on the main thing that drives the most business value, data products. As these get built and consumed in a self-serve environment, the ability to show value becomes much easier and easier for the chief data officer to demonstrate success. Now, when you think about the problems that are tackled by doing this, lack of visibility into jobs and data sets, owners and systems, missed SLAs, falling short on current goals, and the bar being raised every day around SLAs, uncontrolled costs, which can be stemmed from poor communication between groups, between executives, finance, business, engineers. Most companies we talk to are now working in a multi-cloud platform. There's no one company that's using one cloud technology for everything. And just way too many tickets. This gets overwhelming and almost impossible to manage and results in a ton of firefighting and finger pointing. Now, doing this with a full team of highly skilled people trained exactly in what you need is every chief data officer's dream. In reality, enabling self-service without a focus on the human capital element is a dead end. First of all, Success with data is dependent on skills in other areas of the company: change management, product management, marketing, finance, and many more non-data roles need to adapt, buy in, and leverage a new way of doing things. Then, when looking at the data teams that are responsible for the evolution of how companies are using data and building those data products that I referred to earlier, there is a major supply issue. I've seen this firsthand over the past decade. Data engineers, analytics, data scientists, data strategists, any role in and around data are all in short supply and an increasing demand. Now, having a full bench of talent in this space is a luxury that few companies can claim, but most would like. This fact alone makes self-service data products incredibly hard for most companies to achieve. When you look across an enterprise, it's actually the #1 skill gap reported by most financial services companies. And I would hazard to guess, if we pulled up another study, it would be the #1 or 2 skill gap across almost every industry. Now, when you combine this with the #2 most impactful skill gap, which is tech design and management, you can see why most companies are facing productivity shortages in truly key areas, and how this is driving skyrocketing costs as they evolve their data stack to be more modern and much more cloud focused. But wait, there's more. The last time I checked, there have been 1 to 2 new technologies that have become very popular in the last 5 years. Of course, every data engineer spends every evening after work and all weekend learning about this new technology so they can be ready and proficient when a company decides to leverage this modern data stuff, right? Or they just do what they can and figure it out as they go, which definitely seems to be the most common path that we are seeing in the market. With that in mind, for the large majority of companies we talk to, this skyrocketing complexity is impacting everything from quality of data products to work-life balance to costs. Now, while I joke about work-life balance, the burnout in these folks is a huge problem. A recent survey suggests that 97% of data engineers are experiencing burnout. 70% of those surveyed identified that they are looking for a new job in the next 12 months, and 80% are looking for a total career change to get out of this space. Just let that sink in for a minute with our current demand for these people. Now, whether we talk to our customers, our prospects, our partners, which include all 3 of the hyperscalers, or the large global SIs, the results of today's evolving landscape with a focus on self-service is driving very high, unanticipated cost and resource implications. Now, managing these costs are critical and take tons of time. Migrating back and forth when you hurt yourself is non-productive, expensive, and frustrating. And in our current climate, any waste, whether it be financial or from an environmental sustainability standpoint for overusing resources, is unacceptable. And let's not forget the fact that these resources are already in high demand and overworked to a point of burnout. So, is this concept of widespread, governed, cost-efficient, environmentally responsible, transparent self-service even possible? Only if you can find the needle in the needle stack. Remember earlier when I said that doing self-service at scale could be very daunting? This is actually one data application. Just a few components and a couple dozen moving pieces, right? In reality, this one app could have tens of thousands of places where the data pipelines could have broken code, bad configuration, and proper infrastructure setup without even thinking about cost. By a show of hands, who wants to spend their time going through something like this to figure out if it's optimized for performance and cost? That's what I thought. The good news is that we're now in a world where AI can help do all kinds of incredible things, from driving cars to predicting your shopping desires to combing through millions and millions and millions of rows of data just to show you the stuff you should care about. Even more, you don't need to be an expert in the data technology that you're looking at to gain valuable insights that AI can provide. It will ask the questions for you, and show you exactly what you can do to improve the things you are focused on. It will take a job that would normally be impossible and show you the best path forward, literally in seconds. I tell my team all the time, excellence in anything is hard. It takes dedication, commitment, and the willingness to get uncomfortable in your pursuit. But in today's world, and with today's technology in business, that's no longer always the case. In some cases, AI can help augment all of us to make excellence easier, more achievable, and possible in many areas of life. Here, it can help provide spend optimization and predictability, drive tremendous productivity increases to those overworked, burned out data engineers, and help combat talent shortages. Ultimately, it can ensure that the business is getting what they need, when they need it, without massive amounts of intervention, firefighting, and cost increases. These are numbers we see every day across our customer base. And the resulting impacts to those customers is significant, and sometimes provides them with capacity they never thought they'd get back. As an example of this, Santander is using Unravel to plan their migration from on-prem Hadoop to Databricks. Before they do this, they are using Unravel to optimize their data products on-prem prior to migration, improve their MTTR times, and provide a predictable cost plan for this environment. Using our AI-driven insights, Santander was provided with a prescriptive infrastructure plan for migration, simplified the root cause analysis for issues, and gets fine-grained visibility at a job level of their costs. As another example, Novartis struggled with visibility into their Databricks workloads, inefficient jobs, and proper infrastructure setup before we started working together. As our relationship has expanded over the past little while, we've helped them to gain fine-grained visibility into their Databricks workloads, provide automated actions for certain jobs, dramatically reduce their costs for both running and analyzing the workloads that are important to them, and quickly identify and fix failures in your applications. Now, joining me today is one of our top solution engineers, Dave Barry. I'd now like to pass the floor to Dave to talk to you a little bit about how Unravel works and walk you through a brief demonstration. Thank you.
That's great. Thanks, Keith. Yeah, so hi, everyone. Just wanted to run you through a few of these slides of Unravel, just so you get a good idea of what the UI looks like and how we go around capturing this data and how we can really show you the benefit of what we can do to optimize all of this for you. So firstly, what we're going to look at here is just how Unravel gathers all of the information of every application that's run across your environments and really breaks that down so that you can start understanding the individual cost breakdown points of each application, each pipeline, or each cluster, whatever type of platform it is that you're running these on, and how we can monitor those differently. So this is what it looks like in Unravel, where we can just identify all of the individual clusters that are up and running. This is on a Databricks example. So we can start seeing all the different cluster IDs in here, the different job names, what type of environment that was, which user was actually responsible for running this, and what workspace they were in, and then really importantly, the duration and the actual cost. And this is the true cost that breaks down to for that individual user and that individual job run. So moving on from that as well, we can then go into really the core and heart of what Unravel is. And this is where we start looking into the inefficiencies identified in those applications and pipelines. And you can see here that they're highlighted under different types of events, such as contented driver, contented CPU, data skew events, high garbage collection time, high IO events, inefficient join conditions, and really importantly as well, like node downsizing event types. And these are all automatically picked up and identified via Unravel so that any user can actually come in and look at what caused the bottleneck or the problem within their application, exactly where in their code that problem lies. Was it in a specific join condition? Were they not utilizing the partitions of the tables correctly? Or were they not configuring the memory capacity correctly for the environment size? And then we give clear, insightful information as to how to rectify those problems. So this is one of the things that a lot of our customers really heavily use us for. And really, this is driving home that self-enablement piece for all of those end users where they maybe not 10-year veterans of writing Spark applications, and really they just need that little bit of assistance into making sure that the pipelines that they are running are really optimal. And then if we actually start looking into what those insight breakdown analysis is, then you can see an example here. And this is really where we just start to identify that we've got two insights that are actually part of the application failure here. The driver failed with an out of memory error, and so did the executor fail with an out of memory error. We then break into the efficiency, and this is really starting to look into more granular detail into the application. And just at a high level here, we're looking at large idle time for executors, load imbalance, and then there's the high garbage collection, as well as the cost-effective recommendation. The cost-effective recommendation is where we're actually going to be able to right-size the environment, so give you the exact right VM types that you should be executing this application on. And then by fixing things like the high GC time, which we've identified here, is exactly how you'll be able to stop this app from failing in the future, and it won't anymore have those out of memory exceptions. It will still be running on an even cheaper instance type as well. And this is really, really important, because a lot of the time when application developers see these types of errors, they will go for the answer being more resource. Whereas actually here we're identifying the fact that it's actually less resource that's required, but fixing the problematic high GC time. And here you can really look into what that recommendation for the instance type actually is. And as you can see in this example, this is saying that we should change both the driver and worker from a standard DS3 v2 down to a standard F4 SV2. As you can see, that's about half the memory capacity. So really being able to utilize the correct instance type is going to save you lots of money. And even on these really short running applications, where normally they wouldn't be the perfect identified application for optimization, when you've got these applications that are running multiple times a day, the accumulative cost benefit for making one small change on this type of pipeline can be really, really beneficial to the organization. And then with all this granular data, obviously one of the key things in Unravel is being able to look at the cost and the chargeback across the whole organization. So again, in this Databricks example, we can summarize this up by user and by workspace, or by a project, or by clusters, or by utilizing any of the Databricks tags that you've natively got there as well. And this is just a really good way of understanding who it is across the department that's actually utilizing your capacity of DBUs, and really being able to get that breakdown at an organizational level to say, okay, well, this team is utilizing, in this case, my fraud detection team. They've gone in here and utilized 23% of my cluster runs, but they're only costing me 14% of my overall cost that's going into Databricks. So being able to have that granular breakdown, and we can drill down even further than this as well. So you can start understanding individual cluster run costs, as well as user costs, and being able to make sure that departments are utilizing the expected amount of resource, and they're not coming in saying, we think we're going to consume around 1,500 DBUs a month, and actually they're coming in and using more like 5,000. So being able to understand that at this level and have an automated out-of-the-box chargeback report that's constantly being refreshed and updated is really, really valuable, and one of the most common things that all of our customers are using us for. So as I say, we obviously would love to give you more in-depth demos. So if there is any time, please come over to the booth. But as it is now, thank you for your time. And if there's any questions, please, I'm happy to take them now. So thanks from me, thanks from Keith, and thank you for all being here.